Hey guys, so welcome in. Sorry I could not be with you today, but I just wanted to go over with you how to construct free body diagrams. So free body diagrams are quite literally force diagrams where we're figuring out how forces are acting on an object. Okay, so a free body diagram is a simple diagram to show the size and direction of all forces on an object. And we use this by boxes and arrows. So we try and simplify it down really, really easy. So the construction of a free body diagram. First, we're going to draw the object as a point or a box. So for instance, this box, it could represent me, or it could represent a sticky note, or it could represent my cat diorama here. It can represent anything, but whatever object you're representing, you're making a box, and then you're going to have a point on the box as well. Then you're going to draw arrows as your forces going from the point. And then you're going to aim the arrows in the direction that the force is being applied. So for instance, if I zoom backwards, right, the push from me going backwards would make my force diagram arrow go backwards. So let's do some examples so it makes sense. So example 1, we have a grocery bag that rests on a table. Okay, so if we're observing the forces that act on that bag, well, gravity, right? We always have gravity. So we know we have gravity. All right, now if you guys did your force notes from yesterday and you guys did your lean notes, you guys will also know, okay, if just gravity was acting on it, then it would be accelerating towards the center of the earth, right? And it would squish through that table. So we also have a normal force, which is basically the grocery bag pushing back up on the table. So that way it just stays still. If you don't know what I'm talking about, go back to your force notes. Okay, so if we have that example, so far we wrote gravity and normal forces. Now let's talk about the direction. So the direction of gravity, I'm just going to simplify and put G. Well, gravity pulls us down, right? Right, that makes sense. Now, normal, I'm going to say that's N. The normal force, that's going to push us up. That's going to keep us from falling straight through the table, right? Keep that bag from falling through the table. So we have a normal force going up. All right? So with all of that, to make a free body diagram, it's going to look something like this. So we're going to have the force of gravity going down and the force of the table, or the normal force, going up. And you notice how those arrows are of equal size, right? They're of equal size because there's no motion going on. Now, if we made the force of gravity much, much, much greater than the force of the table, or the normal force, then that would show that when we put the groceries bag down, the table is going to absolutely break and all of the groceries are going to end up on the floor because it was too heavy to support by the table, okay? So size of the arrows matters, okay? And notice how we started the arrows in the middle of the box. So that's just showing that's like kind of like the center of gravity, just like somewhere in the middle there. And they're going in opposite directions, the same amount, the same size of the arrows, which means that they are the same force, okay? All right, so scroll through the rest of the examples, see if they make sense, and then take the checkpoint to see where you're at with this. All right, I'll see you guys Wednesday.